everyone. We are very excited to introduce our speaker, Arthur Berrill. Arthur is Head of Data Science at the Royal Bank of Canada. His work is around research and deliberating data science capabilities to the enterprise, including but not limited to location intelligence, ontology, and climate change studies. He has more than 40 years of experience in architecture, design, and development of enterprise spatial systems and holds numerous keys and value patterns in location intelligence. We are very excited for Arthur to speak about his work. Passing it on to Arthur.
Yeah, thanks so much. Within the imagery space, we've got some very active projects actually doing feature extraction, and I'll come to a little bit of detail on that. I'll also explain a little bit about some DAs and how important they've been for our work. I'll speak a little bit about the connection between location intelligence and AI, and I will not deal with IoT and IOH. I think most people know about that, know of it as a great source of data. I will, however, speak just briefly about the carbon ecosystem and how that fits with supply chain management at RBC. And I will skip over tracking data and ground sampling in the interests of time. So next slide, please. This is where it starts to get interesting. Yes. This slide is about the imagery work that we actually have active. So we are looking at detecting vehicles in some of the imagery, and we're trying to correlate the vehicles with the motion that we can deduce from the transactions that we have. And that deserves a little bit of explanation. If you go to a gas station and you buy some fuel and you use your credit card, within milliseconds of you using your credit card, we know that you were at the gas station and we know the transaction, fairly obviously. But the fact that you're at that gas station and then subsequently you're at a Tim Hortons gives us a clue about the time and distance between those two sites, and we can deduce fairly accurately the route that you use to get between the two sites. Now that's fairly intrusive for an individual, but what we do is we have RBC processes 800 million transactions a day. And if you average that across all of the road segments across Canada, you can get a very clear picture of not only the people moving in space and time, but the inclination of those people. So you could literally say that this road segment passing this particular facility between 9:30 and 10 o'clock, the people traveling that are going to be interested in, let's say, home improvement. So the vehicles are an important part of that. They fit into that. It's part of that analytic. We're also working very aggressively in the mining space because we want to actually see that people are that things are changing. So it's of immense importance to us to understand how that mining activity might be influencing the climate. You may remember the big fires that we had in California last season. The smoke plumes from those fires, we've done some work on analyzing the content of that smoke, and that gives us some clues about how climate change might be affected by the smoke. We're also interested, of course, in sequestering carbon, and RBC runs a carbon desk where you can trade in carbon. That trading has a valuable extension in that you can be a bank, so you can actually store carbon, but that has to be verified. So the way we verify that is by calculating the tree canopy volume of the trees that are actually on your property, and that gives us a fairly accurate understanding of how much carbon is being sequestered there. Of course, vegetation type's important there as well. And I will skip over the greenhouse gases to the next slide, please. Just watching my time here. Now, a very important discovery for us, and I'm sure there are people on this call who are much more expert than we are, but we've been using a lot of synthetic aperture radar. It has the huge advantage that it can see through cloud cover, it can see through smoke. But it also gives us clues about soil permeability, and it gives us some understanding of the physical structure of buildings, so we can actually see a bit of the three-dimensional aspect of the building from the synthetic aperture radar. Now, when you combine that with, next slide, please. If you combine that now with hyperspectral imaging, where we have a massive set of slices of spectrum, we can deduce all kinds of very useful and interesting information about what's actually going on the surface and how that might actually be affecting climate change. Now, I'll pause for a moment here, because there is, you may be wondering about why would RBC actually care about climate change. Well, we do, fundamentally, but the money is where the mouth is. So last year we declared that we were going to achieve a goal of 100 billion, that's with a B, dollars in sustainable finance within 5 years. At the end of last year, we were at 100 billion in sustainable finance. So this year we've declared a $500 billion target for the next 5 years. Would you care to guess where we'll be at the end of this year? I suspect we'll knock that one out of the park as well. So there is a huge aspect to this, not just in sustainable finance, but there's a huge aspect in the sense that if we pay attention to climate change, there is an enormous potential economic benefit there, not just preventing risk or mitigating risk. You go to the next one, please. I'm back into location intelligence tools, and this is where location intelligence and AI collide. We have a tool that we've called sub-DAs, not very imaginative. If you're at all familiar with Statistics Canada, they divide Canada up into a collection of relatively large polygons called dissemination areas. And that's the finest granularity that StatsCan uses to publish data. Now, they're very useful, but the aggregation for anonymization that StatsCan does means that they're also very coarse. But with the very fine-grained data that we have, just to give you an idea of how fine-grained it is, we have in Canada 15 million addresses, or actually a bit less than 15 million addresses Canada-wide. We have a customer in 12 million of those addresses. So that is a very sufficient proxy for an understanding of the population of Canada. But that data is a bit inaccessible because it's just so massive, and we also have to be extraordinarily careful of privacy. So what we do is we execute what's called a multivariate Voronoi tessellation of Canada, and it actually breaks Canada down into homogeneous regions defined by the multivariate combination that we've chosen. And on the right-hand side, you can see how the sub-DAs have been broken down. That's a raster representation. We also do it with vector. This has all kinds of useful benefits because we can actually execute one of these sub-DA fabrics taking into account climate change aspects. We can execute one of these taking into account climate change risks, like the catastrophic risks, like floods and fires and so forth. But we can also examine it for the softer aspect, you know, propensity to pay attention to recycling or propensity to be aware of the climate around you. It's a very useful tool, and we've been exploring ways of using that outside of RBC because the data can be guaranteed to be anonymized, and it's not reversible. You cannot reverse engineer it. Next one, please. And just to prove that we're actually building real, live, useful tools, these three tools are in production now. When I worked with Amir, I think these were just a glimmer in our eye, but they're now real Amir, and they actually work. I'll very quickly dance across these. The one on the far left, this is a tool that we use to understand the relationship between climate change and financial performance of a business. And it's not just about whether the business gets flooded, nor is it about whether the access routes to the business have gotten flooded. It's about things that are much more immediate and much more frequent. Now, the image there is a little bit small, but on the left-hand side of the image, you can see the routes that are highlighted in red, and then the one on the right, the routes that are highlighted in red. So this is actually a store, a downtown store, a real store with real transactions and real trajectories from those transactions. On the left, the temperature was reasonable. On the right-hand side, the forecast was minus 35, minus 30, I think, actually. That's a typo. As minus 30 degrees. And people don't go out in minus 30 degrees, and you can see the evidence of that. So that's in one day, but we can rock that out into the future and understand how the profile, the business profile of that store is affected by relatively minor or fairly major climate change. The middle one is much more oriented towards extreme weather. So we actually used this ourselves when Hurricane Teddy came up the coast. Our business continuity people looking after Halifax, they came to us and said, "Can you tell us which of the RBC clients are going to be challenged by the hurricane striking Halifax? And can you give us where's a safe zone for them to move to and to preserve personal safety?" And within an hour, we had that recipe out to them, and they started moving people around to accommodate the hurricane. On the right-hand side is a much simpler version, but it's climate risk assessment for properties pre-purchase. So can I have the next one, please? And don't worry, I'm pretty much on time, and I think I'm finish on time here. Now, this is definitely not a complete list, but these are the data sets that we're very interested in and have been investigating as additional feed to the machine learning models that we use for climate change. And I put these up here just in case people haven't been thinking about them, or in case people have ideas that say, wait, you've missed one. I don't know if anybody's done any work with vehicle telematics, but the more advanced vehicles, there's a great example of a Mercedes telematics set from, I think, about an hour's drive, and the data's into the gigabytes of data. They're literally instrumenting everything. So we see all kinds of potential there for looking at climate change. Obviously, we're going to have to use machine learning for this because it's unassailable with any other tool that we have. But the notion of understanding what imprint those vehicles are having on the climate and on Earth is pretty fascinating. Now, RF noise is an unexpected one as well, but we think this is really important because if there is RF noise, it is most likely caused by humans. So that correlated with the imagery gives you an idea not only that there's a car there or that there's vehicles on the road or vehicles in a parking lot, but if there may be somebody inside, the RF noise is picked up. Now, obviously, we don't hear what people say, but we can pick that noise up. It gives us another dimension. Deep census analytics, that's fairly obvious. I mentioned earlier about movement of populations, but what about the transactions that RBC records? So the hypothesis here, and this one we haven't made a lot of progress on yet, but the hypothesis here is Amir pays his hydro bill. So he pays it through RBC, of course. Amir would never go to another bank, right, Amir? So he pays his hydro bill. Now, we know with considerable precision the carbon footprint of the generating plant and the infrastructure that delivered that hydro to Amir, which means that a small fragment of that carbon debt can be transferred to Amir, and he owns it. Now, admittedly, not every transaction can be carbon imprinted in that way, but there are sufficient of them that we think we can get a pretty good idea of how carbon is moving around Canada in real time. And if you understand that, then you have a live model that you can perturb and understand what the consequences of change might be. We think that's a very valuable thing. Let's skip to the next one, please. I'll go through this fairly quickly. The most important one on the list is the combination of location intelligence and AI. That's something that we've very much pioneered, and I would encourage anybody who's working in AI to think laterally about how the location aspect of this can be used. The location aspect adds a dramatic new dimension to the data, and the pun is absolutely intended. But that change, that meshing of the two, we've never found a case where one of our big models fails to be influenced by LI, and in many cases it's the dominant feature. So I encourage people to think a little bit about that. The other one on the list that I'll emphasize just a little bit is digital twinning. I don't know if folks are familiar with digital twinning, but it has a machine learning aspect to it. The idea behind behind digital twinning comes out of mechanical engineering, and it was first used in 2010 to create a digital version of a spacecraft at NASA. And by creating that digital twin, they were able to correct imperfections in the craft. They were able to analyze the way the craft would behave in certain situations without destructive testing. So I've been working on digital twinning for quite some time, and the idea behind this is that we can digitally twin a city. So instead of digitally twinning a mechanical device, we're actually digital twinning the behavior of a city. And so I'll leave that for you to think a little bit about, but it's a technology that we think has a great future. And last slide, please. This is my chance to make an impassioned plea. As you can probably tell, I'm very passionate about the climate change agenda and understanding how we can contribute to it and helping RBC to be a big player in it. But I think it's much bigger than that. I think Canada is actually in a fantastic position to take a real leadership role in the world in mitigation of climate change. And my evidence for that is, first of all, Canada is one of the top places in the world for AI. I think we've got some of the top luminaries in the world in Canada. We have an opportunity to really take a top-end leadership position from that aspect. Little known fact, location intelligence actually originated in Canada, and we've kept the flame alive. So that part, we should be able to dominate that as well. We have a huge area that we can experiment on. We have a much easier situation with respect to partnerships, and Berrill mentioned Statistics Canada. We called them up. We had a meeting. The chief statistician came along and said, yes, we'd love to partner with you. There are a lot of countries out there where that partnership would take months or even years to put in place. And we've got original technologies that are being grown here. Our current databases, which I won't go into right now, digital twinning, plus we have a remarkable density of data given the low density of people. So we have a great base to work from. So I'm encouraging everybody to pay attention to climate change, get involved, get yourself, help us make Canada the leader in this space, or one of the leaders in this space. And that's me done.
Thank you so much, Arthur.